Let's take a look at this example. A train starts from rest at a station and travels with a constant acceleration of 1 meter per second square. We would like to find the velocity of the train when time equal to 30 seconds and the distance traveled during this time. Okay, so if we recall the three kinematics equation for the case that the acceleration is constant, so we have v equal to v0 plus at. We have s equal to v0 t plus a half at squared, and also we have v square equal to v0 square plus 2as. So for this case, we know that train start from rest. That is mean that we know v0 equal to 0 meter per second. Okay, we already know v0. Okay, we know the constant acceleration. We know a. Okay, we would like to find velocity. Okay, so this is better to use this equation because we know v0 right, we know a, okay, and we already know time, that is t equal to 30 seconds. Then we would like to find v. Okay, so for the first question, we use this equation, that is v equal to v0 now is equal to 0 meter per second plus a is equal to 1, right? And t equal to 30. So then it means that we have v equal to 30 meter per second. Okay, this is the first answer. And the second one, we would like to determine the distance, s. Okay, during this time. Okay, so we know v0 rate. Okay, we know time, we know a. Okay, so then we would like to determine s. So that we can use this equation, that is s equal to v0 t plus a half at squared. And v0 is 0, right? Okay, and then it's become a half, a is equal to 1, t equal to 30 squared. That is become 450 meter. That is the second answer. Okay, so for next problem is the rocket problem. Okay, during a test, a rocket is travel upward at 75 meter per second when it is 40 meter from the ground. At this point, point A, that is 40 meter from the ground, the engine failed. So it means that its wheel goes up with this initial speed, okay, and with the constant acceleration downward from gravity. Okay, so then it is the speed should be reduced until it leads to the maximum height. At the maximum height, the rocket tend to move back to the ground. So the direction of the motion should be changed from goes up to goes down. So at this point, at the maximum height, the velocity should be equal to 0 at this point. Okay, and we would like to determine the maximum height. SB, that's the rocket goes, okay, goes up to the maximum height at this moment. Okay, so we know VA, right? We know VB, okay, and we know gravity, and we would like to determine S. So then it's better to use this equation, that is VB square equal to VA square plus to A. Okay, SB minus SA. And for this case, we consider the motion from A to B. The motion is start from A to B, and the rocket starting moving with the velocity of 75 meter per second. That is, we already know VA. 75 meter per second goes up. Okay, and normally we will use the positive direction, follow the initial velocity. Follow the initial velocity. But right now, initial velocity for this case is VA, that is goes up. So then we normally set up as the positive direction when we determine the motion in the period of A to B. Okay, and VB, we know that it is at the maximum height. VB is equal to 0 meter per second. Okay, and A is equal to the gravity, that is equal to 9.81 meter per second square. But it goes down. It's normally it goes down, so it should be negative. Okay, and SB, because we set up goes up at the positive, and the data is at 0, is at the ground. Okay, so then it's measure up. Okay, this is SA. Okay, and measure up, that is SB, is the unknown. SB is the unknown. And SA, we know that is equal to 40 meter. Okay, so from this information, we can substitute into the equation with the positive sign conventions of goes up and positive. Okay, so VB equal to 0, right? Is equal to VA. VA is equal to 75, right? Plus 2A. A is for this term, it is equal to 9.81. It's equal to gravity. SB is the unknown as we would like to find, minus SA. SA is 40 meter. Okay, so according to this equation, we can determine for SB. And after we solve this equation, we have SB equal to 327 meter. Okay, this is the first answer. Okay, now we have SB already, right? SB is equal to 327 meter. Okay, then we will consider next step, that is when the rocket is at point B already and is try to moving down by free falling. When it's moving down back to the ground at point C. Okay, so then we will consider the motion from B to C. At this moment, we may set up the initial point at point B. Okay, point B as the initial point, starting point over here at point B. So at point B, the rocket is tend to go down. So then we set up down as a positive one. Okay, and if we set up the starting point at point B, it means that at this point, SB is equal to 0, right? Because it is the starting point at point B. It's start up. Okay, and it's moved down to the ground. Okay, move down to the ground, which is equal to SC. That is, SC is equal to what? SC now is equal to 327. Okay, meter. Okay, now at this moment, because we know the distance, that is moving from point B, starting point B, moving back to the ground. at point C. Okay, and we would like to know VC at the ground. That's now we don't know, right? Okay, and A is equal to gravity. That is goes down. Down is positive. So then for this case, for the motion from B to C, we apply the equation, the same equation, that is VC square equal to VB square, okay, plus 2A, okay, and SC minus SB, okay. And now, because we set up goes down as a positive, because we consider point B to point C, okay, the rocket tend to goes down, okay, so then we may set up down as a positive, okay. If we set up down as a positive and starting point is set up at point B, so then it means that now SB is become 0 and SC is become greater than 27 instead, okay. And VC, we don't know, right? But VB, this is the maximum height. So then VB is equal to 0 plus 2A. A is 9.81. It is positive because we set up downward at a positive. Time 327. Okay. So then after we solve this equation, we obtain VC equal to 80.1 meter per second and goes down. Okay. That's all for this problem. Now we have two solutions. That is VC equal to 80.1 meter per second and SB equal to 327 meter. Okay, so that's all for this problem.